Coffee has 566 outlets around Malaysia. It's a Malaysian coffee chain that was founded in 2019. 2.1 Arrival characteristic. First, the size of the calling population. It is infinite, means unlimited. There is no limit to the number of potential customers who can arrive at the system. Second, pattern of arrivals at the system. Random arrival with a Poisson distribution. The arrival rate is 7 customers per hour, which suggests that the between arrivals follows an exponential distribution. And the last is behavior of the arrivals. Patient customer. Customers are willing to wait in the queue without leaving before being served.
As for the characteristic of the waiting line, the length of the line is defined as unlimited, which means there is no limit of how many customers can wait in the queue. And for the queue discipline, it follows the first in, first out approach, which is the first person to wait in the queue is the first person to be served.
Next, we move to the service facility characteristic for Zeus Coffee Cafe. First, the number of channel in Zeus Coffee is single channel system, which is they have only one counter service for customer. Second, Zeus Coffee have multiple system because the customers will receive the service from two stations, which is payment and pickup. And last, the number of waiting line in Zeus Coffee is single line.
Next, basic queuing system configuration. In Zeus Coffee, they are using a single-channel multi-phase queuing system. This setup is quite common in processes where there is one-man queue but multiple stages of service that customer must go through. Think of a customer at Zeus Coffee. They arrive at the waiting line and proceed to the payment counter where they submit their order and make the payment. This marks the first phase. After that, they proceed to pick up their order, which is the second phase and the end of the service process.
The waiting lines for Zeus Coffee from 7:45 p.m. to 8:45 p.m. 1 hour. Zeus Coffee have two different counter, single channel multi-phase system. First counter is payment counter and pickup counter. So here we have two different mu and the same lambda. First mu for the payment is 42 and the pickup is 19.
Next, I will talk about the calculation result that we got for the queuing model for payment. We got three information. The first one is the service rate of 42 customers per hour and arrival rate of 7 customers per hour and the server, which is one server. From the calculation, we get the average number of customers in the system, L, which is equal to 0.2 customer. We also get the average number of customers in the queue, LQ, which is 0.03. Then we get the average time the customer spend in the system, W, which is 0.03 hours or 1.8 minutes. And the average time the customer spends waiting in the queue, WQ, which is equal to 0.005 hours or 0.3 minutes. And the last two is we get the utilization factor, P, which is equal to 0.17 or 17%, and the probability that no one is in the system, which is equal to 0.83 or 83%.
Next calculation is for queuing system at pickup station in Zeus Coffee. From the observation that we do, we get the mu 19 customer per hour, lambda 7 customer per hour, and S equal to 1 server. First, the average number of customers in system use the formula L equal lambda divided by mu minus lambda. Then we substitute the value of lambda and mu into that formula and the answer is 0.58 customer. Second, average time the customer spends in system, which is the formula is W equal 1 divided by mu minus lambda. After substitute the value, the answer will be 1 over 12 hours, which means 5 minutes. Third, average number of customer in the queue, where the formula LQ equal lambda power of 2 divided by mu multiple with mu minus lambda. So the answer is 0.21 customer. Next, we calculate average time a customer spends waiting in the queue. The formula is the same with average number of customer in the queue, but this time the upper lambda is with the power of 2 and the answer will be 0.03 hours. Second last, we calculate for the utilization factor, which means the probability that the service facility is being used. So we use the formula lambda over mu and the answer will be 0.37, where it is 37%. Lastly, we calculate the probability that no one in the system using the formula 1 minus lambda over mu and the answer is 0.63, which means 63%.
Okay, now as we reach the conclusion, from the analysis, it can be concluded that the current service rate is sufficient to handle the arrival rate. This demonstrates that the system ensures a smooth and organized customer experience. Also, no additional service is needed to ensure stability and manage the workload effectively.